Hello everyone. Today we are going to do the basics of data management in R. Okay. So the data management is like just taking the variables, creating a new variables, means filling the missing values, sorting, merging, subsetting the data. So these are all some of the things we are going to do. So for that, today also I opened the Kaggle website. So here today just looking into this housing in London, and this is related to price sales, historical prices and sales, crimes, resident satisfaction, salaries by borough rate. Okay, so that's what this data set is about. So I'm going to create a new notebook on this. So I'm going to click on this. Okay, so once I click on this, actually it will create a new notebook. But before that, I just want to see like how many files are there in this data set. So there are two data sets, one by yearly and another one by monthly. Okay. Yearly it is different because there is some kind of aggregation is applied, like median, mean and all, it's been taken, and some of the attributes are okay. And also housing, it is like number of crimes, bar of land, average house in monthly. So let's start create the new node. Okay, so it has opened a new tab. Okay, so this is the new notebook. You can see it is having this two different files as an input file. Let's start reading. Okay, first step is first give a different name like data. I will say like data pre-processing. Yeah. Okay, it's housing data pre-processing. Okay, this could be sufficient. And it's the only package that I load is mostly this library words, but mostly I will try to do things with most of the things whatever inbuilt in R itself today. Then we'll just proceed to any of the functions if it is required to use tidyverse. Okay, so that's first, and we know, so we can see I've tried this. We know that. So I'll just run this again. And I have usually run this twice because I just don't want to see the display of images of that number of means what all the packages loaded in tidyverse. Basically, it will load the readers and tidyr and ggplot for plotting and all. Okay. So here, what I'm going to do is I'm just going to set a directory path as input. So, and then its input is housing in London. Okay. Housing in London. So from this input directory, if we want to see what all the files in it, just go to this input and just go to it. So this will just okay. So we are missing something. London. Okay, it's hyphen. No, underscore. Okay, there are two different files. Okay, so what I'm going to do is to read first this monthly variables and then we'll see like, or else since I'm interested in this yearly because it is having more variables. So right now I will just focus on this one. So read CSV. Okay, so this paste. separator is slash. Let's see whether it's working. Okay, it has read the files, but mostly I don't want to see this entire list whenever I read. So if you already know about the file, you can just go and mention the call types. There are some easy ways to mention this call types. Okay, but before mentioning any call types, let's see what is there in this data. Okay, so that you read this again. So this is character, this is also character, this is date, this is double. Okay, it's a numeric value. Life satisfaction, I don't know why it's double. We'll see. Maybe it means some. This is mean salary is mentioned as character. Maybe some values in that could be mentioned as some with some characters. So this is also character. I don't know why this also looks like a numeric one. Population size is double. That's fine. Number of jobs, that is double. Area size double. Number of houses double. Borrow flag is also double. So before that, we will see what are all the values before you reset the types to different values. So let it be, I don't want to change anything, but in case if you want to mention call types, you can just say like in a single string itself you can mention, say for character, first column is character, second is character, third is date, so we just mention capital D. If it is small d, it is double. So then the other one is median salary is double, life satisfaction is double, mean salary is character, recycling VCT is character, double, double, number of jobs double, area size double, number of houses double, power of flag double. So you see that while reading, if you mention the column types, if you already know about the file, so it will remove that, showing that whatever the assumptions you took on each of the columns, so that will be removed because you have mentioned the column types, right? So that's it. So but still whatever the column types it has given, I just gave it again so that we will work on the subsequent process of changing these types into appropriate types. For example, if we take this life satisfaction, I don't know why it is a double. Let's see what kind of values it has. So for df, so I'm going to type actually life satisfaction. Mostly in this, I'm just having, it looks like double. So it is some kind of rating, some kind of average. So this can be double itself as it is, okay, but it is having a lot of ns in it. Let's see how to do this. And this mean salary, and just see, as there are some characters got introduced in this, so it's not completely numerical, so that's why it has been given the type as character. Actually in R we have a method called parse integer, so we will use it and see how these values are changing. So let's try that. So parse, so you can either use integer or a number. Since I will go with number because let's see what happens. So you can see for characters other than numbers, it has shown like where and all it has appeared. So in those places it would have introduced NA. Okay, I think that would be appropriate for us. So this is an appropriate way of setting the value. So we can use it like this to assign it back. Okay, now I don't know whether it will change the type of it. Let's see. It is now double. Okay, so even if we do a summary of that, let's do a head again because I ran this again to create a new. Okay, it is now double. So if I do a summary of DF mean salary, so I'm able to see whatever kind of summary you receive for an numerical value. Okay. The next is in our list is recycling PCT. Okay. So let's see what kind of values it has, because it has been mentioned as character. I'm assuming it could be a factor, but okay, it is like from 0, 1, 2, 3. So it is having several numbers and also NA as a string. Okay, we'll just put it like this. Okay, it is having NA as string or any object, I don't know. Maybe I'll put it as summary again. So this will not give the name of okay. So this is some kind of factor only, I assume, because it is some number, some range. But we will do understand about it. Right now, I want to keep this variable as it is. Population size, number of jobs, area size, number of houses, borrow flag double. Let's see what is the borrow flag. I use this table usually just to see what kind of. So I assume this is a factor. I cannot take this as a double, so I'm just going to convert it as factor. Use dollar flag levels. Since people who don't know factor, it is just to convert a value into a categorical one. Okay, this is. But before that, before moving into factor, we have to just convert into a character. Or else we can keep this as it is. What you say? Maybe something like true or false. That could be the proper way of converting it, because just doing it as a factor and then as a character. Borrow flag means whether it is bought or not is what, borrowed or not is a flag. So what I'm thinking is, so this kind of questions may arise while doing your analysis also. So since if you already know the business point of view of that variable, then you can just go ahead and convert it into a factor. But right now it is something like it is showing it as 0 or 1. So means my thought is like just wanted to convert into the factor. Okay, so I'm just converting it as factor. So df borrow flag. So now we'll go to this head df. This shown as factor. So it is one. So now it is factor. Okay, so this is something we just did initially on this data to get a view of what the values are and just converting into a appropriate types. Okay, so we'll just go step by step, like how to create a new variables in this, and then we'll go subsequent. Okay, so let me put it as a markdown, say something like new variables. It's new variables in the sense new attributes as a column in this data frame. So we have something like median salary, mean salary. Okay, so we know what is median and what is mean. Since median is the middle value, mean is just an average value. Okay, so we'll just try to see whichever is. Means we will try to create some variable like something like df mean salary plus df another value, say like mean salary, and then dividing it by 2. So it's kind of taking an average between these two. Okay, so right now I took an average. I'm just putting like creating a new variable average, but this is just for to showcase how I'm creating a new one. We can also use transform method, which I'm just put for you to understand. Transform is another method in R. So in this actually you can just say like df, you can assign it back, transform what object you want to transform and what variable you want to introduce. Then you mention like what is the operation that you are going. So this is something like in here you just no need to mention this as two different columns. So I'm going to mention like this. We can use this, both are same actually, but there are two different ways of doing it. Okay, so but this one is more handy, but this transform is kind of using a built-in method. So right now I'm just assigning it. Let's take the head of data frame again. Let's take a look. So you can see right now this average salary is being displayed. Okay, so this is one thing, like the use of creating a variable. It's like adding a new column as a kind of a feature engineering from the existing column. Okay, the next is recoding a variable. So recoding a variable means you just apply some logical operation on the existing one and then creating a new variable. Say like I'm just putting it as recoding. So this is like headers. Okay, if you mention it as, so as you increase the size, it is changed. So usually I'll use 4. So recoding a variable, as I already explained, means just making use of this existing columns and then encoding means making use of it to create a new columns, or you can just modify it. So for example, I just want to create a borrow flag as some new column. So let's just create this borrow. Okay, so it's borrowed. So initially I'll set it with NA. So now if I just go and see what is that, so you can see is borrowed is NA. Okay, so but right now I just want to show like something like df is borrowed. Based on that I'm going to set it to a condition, some value. Okay, so what condition is where borrowed flag is borrowed, and so it is, actually I'm just trying to press this tab. Okay, let's try borrow flag is equal to 1. So since it is already NAs, I'm just trying to see like for this one I'm just going to give the value as borrowed. So I'll just say like yes, and for the values of 0 I'm going to say no. Let's run this and see what is that. So now we can see yes, is borrowed, yes. This kind of simple one. Okay, so actually right now it is shown as character, that one also we can just convert into a factor. So is borrowed factor, and the f is borrowed. I'm going to set the levels C yes as the first one. Now I'm going to say like head. Now it is a factor. And before moving to the next one, like to see what is the next subsequent reprocessing, I just want to show like some of the useful functions in R. Okay, something like structure, head, tail. Some of the useful functions in terms of the data are so something like we can use str of the data frame. Okay, and then you can see what are all the types that it has, and means what are all the variables, data variables we have, and we can see means the data variables. Okay, okay, and means this is the previous one. Actually we did pass integer, right? So that's why it is showing the list, like what were the expected actually. Okay, means this one is names, which will give the list of columns in a data frame, so that we can get to know what are all the columns available. And using dimensions, you can see the number of rows and columns we have in the data frame. Okay, and using length also you get to know the number of columns. Usually I will use this kind of way also sometimes, but to count the number of columns, but the preferred one is using dimension. So the length actually not only used for data frame, you can use for vector as well. To count the number of NAs in a data frame, we can do is NA of a specific column, but using sapply we can apply a function to all the vectors in a data frame and count the number of NAs specific to that column or a variable. So that's why this is written as a single line. So here you can see like the median salary is having 22 MT and 719, mean salary is 70. So we'll get an immediate picture like what are all the columns are empty values. This is to see how to individually check the NAs in individual column rather than for the entire list. So in a data frame, if there are around some more than 50 features, you can use that sapply. Is less than 5, I would suppose use this individually. You can see that 211 is matching in the top as well. Okay, for recycling PCT. As we progress, the subsequent steps to calculate, or say the next one is to renaming the variables. Okay, so we can just get the list of names. We can use selector to specifically rename the set of columns, or else you can rename all the columns, but usually I use all the columns. But in here I'm just trying to showcase like how to rename the specific set of columns. So here see, I just selected 3 of the columns from 6 to 8. Okay, so you can specify the names in a vector, so for these 3 columns if you want to specifically change. But usually I'll change all the columns, not all the columns, means I'll put all and change the one which is required. This could be like, this will make you to select only the required columns as well. Sometimes after selecting the required columns, you will just get to know just only few columns will be there, so it might not be a huge task to do this replacement or renaming the columns. So right now I just remove this borrowed, instead it is borrowed. Okay, so now you can see it is borrowed. Even in the data frame you can see it is, right now it is renamed as is borrowed. Okay, okay. Sometimes actually I prefer to use simpler names so that you can understand it. Okay, there are few more things of just rename columns. Okay, means you will just select only few columns for your analysis, and also you rename into appropriate names, and then proceed to the further process. Actually, these are all I'm just doing in real time. I didn't do any preparation to showcase how I work. Okay, and this one is actually I'm going to put it as a separate function, so that you no need to write that as apply function again and again. They will create a separate section as reusable functions. Okay, so whenever you have any functions, I will put in that cell and execute it and keep it and test it there itself. So I'll showcase like how I'll add. I'll just put it in here. I'll give it some name to it. So it is like any count. It takes the data as a parameter. And so whatever this data is nothing but a data frame. Then you apply the function on the data frame that will return the count. You can put all your usable function in the cell, and also you have to test it there itself, so that you no need to move here and there in the notebook. So you will get to know only the usable functions that were there, and then start using it in your notebooks. Okay. So this is like data loading step. So initially we'll load this data, right? So just putting. Usually I will use this four hash marks for the headers. I don't want the bigger headers. Okay. So the next steps would be like to impute the missing ones. Okay. So there are several ways to do this process of missing value imputation. Whenever if it comes to any continuous variable, people tend to use mean, max, or median values. It depends on the business, and also people use a machine learning model also to impute a value. But right now, I'm just going to show a simple way in R itself rather than using any of the tidyverse package to impute a value. Here I'm using the NA count to see, and then we'll just pick a column into the imputation. So right now we know the count, right? So I'm going to pick one of the columns to showcase how I'm doing it. So I'm just picking it this mean salary. Uh, Sorry, number of jobs, because which I haven't worked the previous sheet. So there are a lot of NAs in this. So just to filter out to see how before applying any values to it, just to filter NAs alone and see whether you're applying it properly. So we'll just write a filter code in here. So which is a function to just gives the places where it is NA, and then we'll just apply the new value. So I'm going to use mean here. Sorry, I think some function here. Okay, let's just okay. These are all the NAs, and I'm just going to apply the mean for this NA values. But this is not the means a single solution of imputation. As I already told, there are several ways of doing this process of imputation. This is one of the ways, but I cannot advise this to be used in the production always. Okay, but it's a business decision. I'm just using this NARN tool so that ignoring that NA values and calculating the mean. Now you see the NA count got 0. Now it is 0. I'm just trying to do the summary of it to see whether there is any NA in that and how the values are. We can also use histograms to understand the values. Then you do the imputation based on any of these buckets as well. Okay, so I'm just going to do an histogram on it. Just hist. This is building functions. I'm not using ggplot as well. They're all just building function. R functions. Nothing fancy here. So you can see there is a huge growth initially, but there are few more outliers as well. Means it's moving to the end. Next thing is we are going to work on the it's data variables in the sense it's date variables. Okay, so date plays important place because if the data is not in date type, but the values looks like a date, means you have to make sure that it is converted to the proper date type, so that while sorting and also in case if you want to perform any other operations on it, it will be useful for us. Okay, so I'll show you like how from date you can extract few more values from it, and that can be used as another variable. Okay, but right now I'm just going to show it like so for example, if the date is like this, and if you just mention it as date for it, it will try to convert into a date form. But if for few things you have to mention the format, but right now I'm just trying to see if this one works as a data. So this doesn't. So you have to, I'm trying with the slash, it is also working. So this Lubri date is a separate package, but with tidyverse itself it will come. So we can extract few of the values like month, year, week, day, all those things from a date. So you can see it's a month of 5, fifth month, and we can see what is the day or week, and many values are, it's many useful functions are there in Lubri date. Okay, so day, so it is saying second of May, and that can be used as a separate variable in your data frame for further analysis. So on which week it is happening or which month it is happening usually. So how the price are varying in housing. So these kinds of things, by extracting a few more attributes from date, you can do. So if the date is just a string, you have to do string processing. But if it is a date format, you can do it. So I'm just applying a different formatting and showing like how to extract the date from a string. So this is like year. If it is capital Y, 4 digits of year. If it is small y, just 2 digits. So right now we have 4 digits. So it is capital Y, and then M, it's month, and then date. So now it has properly extracted the data. Make sure your variables are properly converted into the date format. Then you work on it for the process, so that the sort also will work. You can see now the sort will perform properly because it understands date right now, because we have for ins change the type of thing. So from this you can know it is up to 2019 12th month. Okay. So I'm just hiding it, the output, so that in the exported version of this notebooks, right, will have a shorter scrolling, or else you have to just scroll. Because right now I'm just going to see this type, check and change. Means like you just check the type of the values and then record if it will change. There is function, list of function like is numeric, is boolean, is logical, sorry, is logical. Other all functions. Check before performing any operations on it. So right now I'm just checking is numeric on date so that we can see it is false, and mean salary it will be true. Okay, it will be true. So there are list of functions with these. Okay, so this as character means it will change the values into a character. And this is just like converting the type from numeric to a string, okay, or a characters. You can also try for as date as well, just to check. Mention as date, it will throw an error, but it is asking for an origin. So if you mention any numerical data and you are trying to convert it into date, it will ask for origin, so that from that date it will calculate it as number of days for your data. So I'm just giving the origin as 1900 So all the numerical values are treated as number of days from that origin. So it has given a different date for you. So you can convert a numerical value also into a date. Make sure you give proper, so you can change the format. Some people will use 1899, but I use 1900. That's my starting. Even the numeric value, we are able to convert it into a state. But some people, sometimes some data in some format will be just as numbers, then we have to convert it as date. but make sure you use proper origin, because if the origin is changed, it will be different. Next, we'll look into the sorting the data. We already seen the sorting of this date as well as numbers. Make sure your data is in proper type so that sorting can be used to easily identify how the values are arranged. This is just to see the min and max of the values, and see to confirm like the values in the top is minimum and the bottom is maximum. Okay, they just included any that term just not to consider the any values. Otherwise, our values will be modified. So now you can see it is 1835 and 90,000. The word sorting is one action. Okay, so what some of the basic data processing which we did. This is all say like to get an initial glimpse of the data. Okay, the next is like merging the data set. There are several ways of merging. If you use internal merge method, you are going to perform a join. The join operation expects the by parameter, which is like by which column you are going to join the two different data sets. This R bind and C bind, it's just like binding the rows and the columns. Okay, it needs to match the number of columns with respect to R bind, and C bind it needs to match the number of rows so that it will bind. So I'm just going to show you like creating a dummy data frame based on the dimensions of the actual data frame which we are working on. Means we just create a sequence of numbers based on the dimension of the first data frame. Then we will just append it to the actual data frame. Okay, there's a sequence number as a column, and use the sequence as one to this dimension of this first data frame. And you have to just mention the first part of that dimension because it will give rows and columns as well. Right now, I just want to know the rows. We just want to know the rows alone. Okay, so you can see it's a sequence of numbers. Okay, so the number of records rows is same as what in number. So to check, cross check in DF, the number of records are same. It's 1071, and there also it's 1071. Okay, now we will do a perform a C bind operation on this data frame. Now we will be able to see a new column in our data frame. C bind of data frame. Now we can see that in the last it is sequence number is there. Okay, the last column is the sequence number. And next is, as you can see the names like the sequence number is there. And then let's see, try to do an R bind. I think I don't want to create multiple column values. We'll see how to do that. You have to, I'm just trying to create a new data frame. I don't think that is required. You can just use this same data frame. Let's try. Just giving the same data frame again, just to see the dimension, so we can confirm like this number of rows got increased because we just want the same data frame again, right? So it is 1071, twice it is 2142. Okay, with respect to merge, you can just check the help we can do left join, right join, okay, and inner join using that, but you just have to play around with this all dot x and all dot y to make sure that you do, if you want to do left join and right join, okay. So there is a all dot x, all dot y. So if you mention true false in these values, so it will appropriately understand whether it's a left join or right join. I don't see an example right here, but you can get to know that. If you specify all data x as true, it is left join. Okay. So the x is what you left data frame and right data frame, then by operation and all data x are all that. Okay. These are all built-in methods in R itself. I'm not using any package. Okay. Even though I included my tidyverse on the top, still I'm just trying to showcase in this notebook with the existing itself. If required, I will use. The last one is subsetting of the data. In subsetting, is we extract the subset of data from the original data frame by condition and also specific columns as well. Right now, we start with some specific columns like extracting instead of just by the number of rows, we'll just extract number of features. So I'll just give you some number. You know, it will be rows, then columns. I'll use vector and then specify the column numbers which you want. Then I just want this first five columns and trying to extract this. You can just assign it to a different variable, or else you can specify the column names as well. Like specifically, you can mention, okay, like this also you can mention an extra. And this one is just taking the names and then it's basically like from 1 to 10. If I don't want to mention the names, I do know that just 10 columns is sufficient. There are different ways. I'm just trying to showcase the different examples. Why I want to include head is because I don't want the people who are looking into this data frame to scroll continuously scrolling, because it might have 1,000 records. But even though if it won't show that, the subset help is this means whatever the data you want to do a subset, and the condition you want to select the specific columns, and then you want to drop off. This drop means it will just remove it from the original one. But we don't want to drop. Usually we just extract the some values. So we'll just take some, say like is Goro is equal to yes. So we know like this is the subset of data which is all the values are yes. So we can see it is 600 plus data. And we can also see using the table method how many values of yes are there in that column is for. So it is 600 not same. Okay, it is matching. So again I'm going to, once you can assign it to a different variable if you want to extract. Okay, so that's why you just keep df yes. Means if you want to see like the salary mean greater than mean of mean salary. So some people just want to see the records which are greater than mean or around mean. So something like that. So this is to see like yeah, it is 3,000 something means 30,000 plus. So the mean would be more than means near 34 or something. Not 34, but yeah, it is 34. So all the values will be greater than that mean. So I'm specifically selecting the columns which is having the means records and also the columns. Okay, that's why it is called subset. You can just go for the records. So I'm just giving the range of columns from area to is for. I'll just ignore the first column. Again, specify the numbers of the columns using vector. Okay. Okay, again, I'm just using the head so to avoid the scrolling. So just to recap, like what all things means, the basic data operations on the data. Like initially, you just load the data, some reusable functions, and then like column types. If you specify, it's fine. So I'm just specifying the types so that it won't show any assumptions it took. Okay, and then some summary of it and table how I created and converted to factor, creating new variables, decoding a variable, and then like using the str to see the structure of the data frame, and then say like names, length, and then counting of this NA and renaming the variables using the names, setting into the names, missing values, distribution histogram, working with the date variables. Okay, so I didn't use ggplot any fancy here. Date variables here. Check and change the type of the data. Okay, using these functions. And how this sort is working on the data. Okay, and dimensions subset of the data. Thanks for watching. Hope it is helpful for you.